All right, so my name is Luís Soares. I came here from Portugal. It's been a while since I was here last time, so I'm happy to be here again, speaking about my favorite topic. Um, I think I'll talk mostly about things that are already done. So I'm not going to talk about things that are to come. But before that, just a little bit about myself. I'm born and raised in Portugal. We knew that already. And I've been doing MySQL for a really long time now, more than 15 years. I've been doing MySQL mostly on replication and HA. So anything related to replication, anything related to HA has been, I've been working on that, except for the MySQL NDB cluster, right? So what I'll talk about is, I think, things that a lot of you know already quite well, like asynchronous replication, group replication, failover, and so on and so forth. I saw that there is some overlap with the previous session, but I don't think there's so much overlap that it will become boring. So this is the proposed agenda for today. Talk a little bit about background on SLAs and RPOs and RTOs and so on and so forth. Then talk about things like the cluster sets, replica sets, and then talk about the service itself, high availability in the service, replicating in and out, replication for scale out with read replicas and so on, and then conclude this session. So background. Often when we talk about SLAs, it's a constructed statement on top of several things, including or heavily influenced by things like RTO and RPO. RTO means recovery time objective, and RPO means recovery point objective. Often RTO is associated with how much time it takes to recover from a failure, while RPO is associated with how much data do you lose when there's a failure, right? Different failures or different systems fail because of different reasons, and different systems have different types of faults. Sometimes faults just go unnoticed for a little while, and when they are triggered, they cause failures and then cause an error in the system, and then all sorts of corrective actions will need to take place to recover the system. But the type of failures also means that the type of failures that the systems can show or exhibit can be catastrophic, like there's a whole region or a whole data center that goes down, or can be just as simple as a single instance failure or process in a host that fails, right? Often, or perhaps not as often, they can also be triggered by human errors, right? So we're only human here. So in MySQL, if we look back all the way to the year 2000, which is when replication was introduced, MySQL has been a database that has replication built in almost from the get-go. So it's a database where the community and all our users have been used to leverage replication to sustain failures, right? So it's a proven technology. It has existed for a long time. It has seen a lot out there in production, and it has been continuously improved over the years. Back then, in May 2000, replication was released with statement-based replication. Over time came row-based replication. Over time came global transaction identifiers, much more flexibility to rearrange our topologies and so on and so forth. And in addition, whatever replication infrastructure, it also was not just for replication. So a big part of, for instance, row-based replication, or a big benefit with row-based replication, is that it brought in a framework to do things like, okay, let's do some sort of capture data change or data integration by easily mining the binary log and integrating the data into other systems too, right? So, well-proven, well-established technology, but every technology which is not by itself a solution requires that some effort from our part, who is managing the system, operating the system, to observe, identify the problems, build some sort of automation, and eventually build a whole platform to operate the system. Fast forward a little bit, and we got to a point that we said, okay, maybe if we can give our users a whole platform, a whole tool set so that they don't have to build the operation framework themselves, they can use our tool set, use our recipes, and then have a common way to deploy HA on their own infrastructures, right? So at some point in time, we started to release things like InnoDB cluster, which is a combination of group replication for the server failover, automation in the server, in the cluster, and so on and so forth. The router to do some application failover. The MySQL shell, which gives you some some recipes or some APIs to do the common tasks that you don't have to write your own scripts anymore. And obviously the MySQL server itself. With InnoDB cluster came replica sets too, and with replica sets and InnoDB cluster came things like, okay, maybe we can do cluster sets to also automate things like disaster recovery between InnoDB clusters. You still need to run, to monitor, operate, and manage, right? Possibly at scale, possibly with by running or while running many different heterogeneous workloads on your systems, maybe across unreliable networks, maybe with multiple versions of the world, in the sense that maybe the network is not so reliable, maybe the system itself partitions, and all of this while undergoing things like maintenance and so on and so forth. So this is still something that the user needs to do, right? So needs to, even though there are recipes, the user still needs to understand that these things are, well, when you're managing this, you need to understand that these things are possible and consider these things, of course. So if we want to, okay, I'm not ready to deal with that, or I don't want to deal with that, we have the MySQL HeatWave service that people can instead choose to use instead of using their own deployment of MySQL. What this means, of course, I think we've heard a lot of this already several times. It's us who's taking the effort to actually manage and operate things on your behalf, and therefore you can spend your time doing productive work, doing the work that you should be doing while using MySQL instead of trying to manage the system, right? So with the service, with the MySQL HeatWave service, we still have the same MySQL server. We give you the user experience that relies on the MySQL HeatWave service console, REST APIs to engage the service. You still have access to Terraform to do your setups as in infrastructure as a service. You have several SDKs to interact with the service itself, so it's easy to script some of the common tasks that you may want to do, and all of this while relying on the Oracle Cloud infrastructure, block volumes, VCN, virtual cloud network, compute, making use of all this powerful infrastructure available in OCI, and it's still the same old MySQL group replication under the hood to give you all this HA. So if you ever use it, or if you have already used it, you'll feel right at home. So a little bit about InnoDB cluster replica sets and cluster sets. So we talked about technologies, and then we talked about solutions, right? Technologies is like, okay, it's left as an exercise for the user to, okay, how do I combine this? How do I build the system together with all these things. And after, back then it was more as left as an exercise to the user, meaning that there were several different ways to do things. Maybe some people would not do the best choices when creating their own topologies and so on. So we figured, okay, maybe we should have a common way, like I said, and test all these things together, package these things together as one product, right? So again, we came up with this InnoDB cluster sets, and replica sets, right? So the emphasis was also, a lot of the emphasis was also on making it easy to use, right? A big part of that is the MySQL shell, which is a very popular tool among our users nowadays. So, replica sets. With InnoDB replica sets, or MySQL InnoDB replica sets, it's still plain asynchronous replication, except that you have all the power from the MySQL shell and the admin API to manage and operate these topologies, right? You have all the recipes from the admin API that will guide you through the process. Within InnoDB cluster, you have basically MySQL group replication. Again, the shell helping you out through the management of all of these things, right? And with cluster sets, you get a recipe or a solution to implement some sort of disaster recovery or cross-region or replication between clusters that help you implement some sort of disaster recovery solution at the end of the day, easily using the MySQL shell too. So the MySQL shell in all these things becomes the one-stop tool to interact with these systems, right? So, now that we covered things that you can do, let's cover things that we do so that you don't have to do them yourselves, right? With the MySQL HeatWave service, we take a lot of these technologies again, and we implement a service using these technologies, and we just give you a turnkey solution where you go in and you create or launch a DB system, and then maybe you say, okay, I want this DB system. It's very precious to me. Excuse me. It's very precious to me. I want it to be highly available because I don't want anything to happen to my data, or I want it to be always available, and I don't want data loss in case of a single failure, and so on and so forth. So that's at a distance of a click. Same thing with inbound replication, right? I think probably a large percentage of the room has engaged or used MySQL replication at some point in your life, right? So you used to do things like change replication source, start replica, and so on and so forth. So all of this is now also easily exposed via the service REST API. And you still have outbound replication, so you can do replicate in, replicate out from the service itself. Another interesting part is all of this is just done by engaging the REST API, and you don't have to worry about things like, okay, I want to do provisioning, now I need to take a backup and restore it there, and so on and so forth, right? So this is all done for you as part of the framework in the service. Of course, I'm referring to things like if I want to turn on HA, I just click a button, and under the hood, the system will automatically clone, automatically provision secondaries, and so on and so forth. Same thing for read replicas, right? You say, okay, I want a read replica in my DB system. The DB system will create one for you. So I think I talked about the features already. The emphasis is, of course, simplicity and usability, right? A lot of effort is put into having a model in the REST API that is easy for you to relate with, easy for you to understand, and at the same time, abstract away a lot of the heavy lifting that you don't have to be worried with when using the service. So, the service itself exposes a concept which is a DB system. A DB system is an abstraction for things like this is a cluster. With the cluster comes things like HA or not, comes things like replicas or not, comes things like automated backups, comes things like point-in-time restore. So the abstraction to all of this is the DB system. DB system is, as you can think of it as your cluster, which has endpoints and then a set of services that run on that cluster. Services like point-in-time restore, backup, automated backups, and so on and so forth. Then, if you want to enable or launch with the high availability in this case, you can, at launch time, you can just say, okay, I want to create a DB system. I'll choose it. I want one with high availability, and then just complete the process, launch it, and then you'll get a DB system with 3 instances, a read-write endpoint that you connect to. In case of the primary failure, it will automatically reroute the application to the next primary. Basically, there will be a promotion, there will be a failover, a promotion, and then the application will eventually hit the next primary, right? The one that was promoted. This happens on unplanned failover. Also happens on planned failover. Like you can choose, okay, I'm not so happy with my primary being on an 81, availability domain 1. Maybe I want my primary on availability domain 2 because my other set of the stack, my apps are actually on availability domain 2 now. I want them to be closer to my endpoint. So you may choose to now switch over to AD2, right? So that's possible. You can trigger a switch over or a planned failover too, right? And failovers can also happen during rolling upgrades, during rolling change shape. You can imagine, right? I'm changing the shape of my highly available DB system. I need to roll it through the system. I need to change each instance to the new shape, and eventually I will need to change the instance that has the same, that is the primaries, to the new shape, right? Same thing with configurations. Some configurations might not require a switchover. Some may, right? So, but the interesting part of all of this is that there's a lot of work that is done behind the scenes to prepare things up front. So when the time comes to actually switch over the primary, it's just a few seconds, a few seconds to actually do this last bit of the operation, meaning just a few seconds of downtime. You can also replicate in and out. It's an interesting type of possibility when we think about, I want to make my DB system HA, but I also want to increase reliability or dependability of the system by having a way to do cross-region replication, or on-premise to OCI, or OCI to on-premise, so that if any of these things completely fail, I can switch over to my other online system that lives elsewhere, right? So this can be achieved with inbound and outbound replication. Not just that, right? With inbound comes the possibility as well of, okay, I'm running things on-premise, or I'm running things on some other cloud, and I want to now use the features that exist in OCI as well. Maybe I'll launch a DB system and I'll replicate from elsewhere into my DB system, and I'll start using the features of that exist in MHS, in the MySQL HeatWave service, like the HeatWave cluster, or some other features like Lakehouse, right? This is just a drawing explaining, okay, you can do replication from MHS to on-premise, or vice versa, right? So it's still asynchronous replication. It's still the same look and feel. There's nothing really very different here. So anyone who has done normal replication or asynchronous replication on premises will feel right at home here too. And with there's an aspect to this thing about read scale out, which also influences the availability of the system. Often, if you have a system, so the worst kind of failures, when we talk about failures, the worst kind of failures are those failures that are not actually failures, but they turn out to be failures, really, like gray failures. Maybe because you undersize your system and then it's struggling with resources, but from the HA perspective, everything looks fine. It's just that it's very, very slow. Instances or processes are responding to pings. They are sending heartbeats as they should, but maybe they are swapping aggressively. Maybe they have exhausted all the memory. Maybe exhausted all the disk, and so on and so forth, right? So an interesting aspect of doing this type of scale out, or one of the reasons people usually do this type of scale out by diverting reads from the primary to secondaries, is to avoid having the system overloaded on the primary instance, so that they don't run into this situation or where the system is unresponsive, but it's actually unresponsive because it's just very slow, because it's lacking resources that it needed, right? So that's one intersection of managed read replicas with HA. But in addition to that, of course, spreading the load, having the system more responsive, faster, and so on and so forth is also one important aspect of managed read replicas. Managed read replicas are easy to create in a DB system. You can just launch them. Launch them means you can just do an API call to create a read replica, and under the hood, in a few minutes, you'll get a read replica up and running. So you don't have to do anything else. Together with read replicas, when you launch one, you'll have an automatic endpoint, which is a load balancer endpoint across the read replicas that exist associated with your DB system. So I'm almost done. Some considerations. So HA is not just responsibility of, it's not just responsibility of the person who builds the infrastructure. It's not just responsibility. It's a trait of the entire system. In addition, it's a thing that has to be thought through end to end. So often, you can have all the best, you can have the best infrastructure possible, but if you undersize it, then your system will start to be very slow, and then you'll complain, oh, why is this very slow? Why is it running out of memory? Why didn't it fail over when it ran out of memory or close to running out of memory? So it's important to know the workload itself, what's the pattern of the workload. It's important to do capacity planning up front. It's important that the application itself, when engaging the database, is aware that things can fail and retry when things fail in that sense. And it's also important that users understand the limits of the system itself. Often, as well, it's good to embrace the technology, knowing its limits, but also understanding how far you can go and seek opportunities to work around, mitigate, or even extend the problem, right? So all of this is really important as considerations in HA. So to conclude, there's MySQL. To me, as a person who likes replication, availability, dependability, and whatnot, it's really a nice and fun place to be. It's a database that has grown it's grown a lot, but an important aspect of this is that from the get-go almost from the get-go was a database that had built-in replication. So with that, there's a very active community, technology, understanding of where MySQL fits in all this HA story across our users. And over time, it gave us the understanding and the ability to reason about, okay, how can we make things easier for our people, for our users? How can we turn the technology into solutions and then make everybody happier at the end of the day, and then take that knowledge as well and build a service out of it, right? So a service that scales, a service that aims at having the same type of considerations as the ones that we put into these solutions, right? So I think this concludes my session. Thank you.